So on September 25th, we had the pleasure of listening to a seminar presented by Clint and Carter on the integration of digital technologies and sensors in the nuclear power industry and in the greater energy industry in general. So he discussed the future of nuclear power, which we've heard on some other occasions as well. And he also talked about the important role that digitization and technologies might play in the nuclear power space. And this is really important because of the potential future that nuclear power has in the energy mix in the US in the coming years. So to support growth in this industry, these technologies like digital sensors, temperature sensors, and even technologies including artificial intelligence are really important to provide real-time monitoring that can be used to increase performance of these power plants and efficiencies and reduce the risk of human error. So Mr. Clinton also discussed how they're researching and implementing this AI technology, and this requires the acceptance internationally of public policy and regulators. And so it's one of the hurdles that we discussed in the seminar as well. So before we get into more specifics about Mr. Carter's projects based on our class discussions, Ava, what role do you see nuclear power playing in the future of the US energy grid?
Well, I hope that nuclear plays a very significant role in the future US energy grid in order to meet climate goals, ensure energy security, and maintain grid stability. Nuclear power is a carbon-free source of electricity, so it's not producing greenhouse gases that contribute to climate change like fossil fuels, coal, natural gas. In fact, nuclear power plants currently prevent the emission of over 2 billion metric tons of CO2 each year in the US. So in terms of energy security, nuclear power plants provide baseload power, meaning they can generate electricity 24/7 regardless of weather conditions. This is in contrast, obviously, to renewable energy sources like solar and wind power, which are unfortunately intermittent and cannot always generate electricity when needed. So nuclear power plants are also relatively immune to fuel price fluctuations, which can make them a more reliable and affordable source of electricity than fossil fuel-fired power plants. Nuclear power plants provide inertia to the electric grid, which helps to maintain stability and prevent blackouts. Inertia is the resistance of a rotating object to changes in speed. So nuclear power plants have large turbines that spin at very high speeds, which gives them a lot of inertia. And this really helps to keep the grid very stable when there are sudden changes in demand or supply. We can go on and on. There are other benefits like job creation, economic development. Nuclear power plants are usually located in rural areas where they can provide a very significant boost to the local economy. In terms of air quality, they don't produce any air pollution like soot and particulate matter, which we know can cause various health problems. And then nuclear power can also support the development of other clean energy technologies like hydrogen and electric vehicles. And this can help create a more integrated and sustainable energy system. So the Biden administration has recognized the important role that nuclear power can play in achieving its clean energy goals. While nuclear does have its challenges that need to be addressed, it is a carbon-free, reliable, and affordable source of electricity that can help us meet our climate goals. And public opinion on nuclear power is becoming more positive as people become more aware of the climate crisis and the need that we have for clean energy solutions. So I really share the same opinion with Clint Carter that nuclear is a crucial path to the future.
Yeah, thank you, Ava. I definitely agree. It seems like as we move forward, nuclear is going to play an increasing role in the energy grid, especially in the United States. I know internationally, other countries have definitely partook more in nuclear development, but hopefully the US is on that path as well. So, Joby, do you think there's any specific areas where nuclear power is lacking right now? I know I mentioned other countries have developed a lot already. And so where might the US and our infrastructure currently need to improve?
Certainly. While nuclear power holds great promise as a carbon-free energy source that can help address climate change concerns, there are a multitude of operational areas, specifically within the nuclear power plants, that can benefit from modern advancements, especially with the ongoing evolution of Industry 4.0 and the digital transformation. I broke it down, I guess, mentally and in my notes into 7 potential areas. The first area I think a big improvement can happen is with digital systems. Transitioning from analog to digital monitoring and control systems for improved precision and real-time monitoring is one huge thing to create more transparency within the nuclear facility and for your power grid. Secondly, automated inspections. You can utilize AI technology or even robots and drones for inspections, reducing human exposure to radiative areas, which increases the safety factor for your employees. Transitioning enhanced safety, implementing automated fire checks, and as I said before, real-time digital monitoring for faster response times during anomalies within the facility. Increased data analytics using machine learning for predictive maintenance on equipment and to foresee potential equipment failures. Modernizing our control rooms, advanced visualization tools, AR and VR for better decision making. With increased technology within your infrastructure, cybersecurity is huge. So with new technology, we'll be able to strengthen our defenses as nuclear plants become more digitally connected. And lastly, we can utilize technology to improve waste management. We can explore different technologies to enhance long-term nuclear waste storage or to even reduce nuclear waste. Implementing these advancements can enhance efficiency, safety, and cost effectiveness of nuclear power plants if we really focus on these 7 key areas.
Yeah, that's great. I definitely remember Mr. Carter talking about some of the areas they looked at in plants, which I remember included employees walking to read analog sensors, to read temperatures, which sounded really inefficient and antiquated. And so it felt like maybe there was some real advancements to be made there, both real time and for the future with waste management, like you said. That's a really great point. So, as Mr. Carter presented in his seminar, he talked about the advanced remote monitoring and diagnostic services project specifically, which I know he's been working on, which kind of encompasses some of these improvements that Joby talked about. So, Mike, what were some of your takeaways from these advancements, especially when he introduced the concept of AI?
Thanks, Jessica. So I'll start with like a little background on the project. The Advanced Remote Monitoring and Diagnostic Service Project is a $14 million project from the United Utility Service Alliance that's aiming to preserve the competitiveness of the United States nuclear energy supply by using advanced technologies to transform key business processes. So like under that project, there's 3 core objectives. And as I just said, there's a business redesign. A lot of the nuclear plants are getting old and operating with older technology. Modernizing these technologies will be done over time in 2 phases. These phases are like, the first phase is looking into 7 business processes, specifically process anomaly detection, shiftly surveillance, thermal performance, operator rounds, radiological management, fire watch, and online transformer monitoring. Phase 2 is a little more out into the future, looking into more advanced processes such as autonomous inspections, autonomous rounds, autonomous alarm responses, and work package initiation. And 9 out of the 12 of these processes that I just said can all be done with AI as the technology becomes available. Another part of the project is to develop a 24/7 monitoring and diagnostic service. And the Utility Service Alliance has been running a center like this for the past 18 years. It's called the Power Optimization Center. And this has already been proven successful. Mr. Carter discussed 3 different cases where the sensor prevented critical failures at 3 different power plants. And since it's monitoring, it effectively acts like a second pair of eyes. Combined with AI, that'll be a bunch more set of eyes on all the power plants that it's servicing. And then the final objective of the project is the creation of New Suite, which is basically putting the last 2 things all together on one online platform shared between the services. New suite will be able to form advanced analytics using the artificial intelligence and be able to remotely monitor plant computers and field sensors. So this will allow for some more core business processes to become more simple, standard, and autonomous. Overall, AI is going to provide an essential component to the nuclear power industry, but for the more advanced processes, it still might take a few times since there are a lot that are still in like the prototype phases.
Yeah, I definitely agree. I feel like as we head into integrating artificial intelligence into more technologies, there's a lot of care that needs to be taken. And I know there's a lot of pushback from the community and from different groups. And so automating certain processes that maybe Joby talked about would be the first step. And then, like you said, moving into the future would provide greater enhancement, but with greater complexity, definitely. So, Mohammed, if there's acceptance of these new technologies in the energy industry, what do you think some of the long-term impacts could be on the nuclear industry and the energy industry together?
Thank you, Jessica. It's clear that the integration of artificial intelligence and the new technology in nuclear power plant operation and maintenance will have many impacts. First one is increasing the safety. AI can increase and enhance safety by continuously monitoring and analyzing a big amount of data in real time, detecting abnormalities or potential issues early. Predictive maintenance powered by artificial intelligence can help in identifying and address potential equipment failure before they occur, reducing the risk of incident. Furthermore, AI can increase operational efficiency. AI application can optimize plant operation by improving efficiency in energy production, reducing downtime, and enhancing overall plant performance. Machine learning algorithms can learn from historical data to make more informative decisions, lead to better resource utilization and cost saving. Moreover, it can enhance decision making. AI system can assist operators in making better decisions by providing data-driven insight and recommendation. AI computing technology can analyze complex scenarios, helping operation response more effective to emergency or unexpected events. Additionally, remote monitoring and control. AI allow for more advanced remote monitoring and control capability, enabling operator to manage plant operation from centralized locations. This can reduce the need for on-site personnel, lowering operational cost and exposure to potential hazards. Not only remote working, but also advanced diagnostic and maintenance. AI-driven diagnostic can identify equipment degradation or failure more accurately than traditional methods. Predictive maintenance algorithm can optimize maintenance schedule, reducing downtime and extending the lifespan of critical component. On the top of that, artificial intelligence have a big challenge with cybersecurity. The increased reliance on cybersecurity, including artificial intelligence, introduced new cybersecurity challenges. Protecting this system from cyber threat become critical to ensure the safety and security of nuclear power plants. That's all.
Thank you, Mohammed. It's definitely apparent that there's a lot to consider when we're talking about implementing artificial intelligence to support industries like the nuclear power industry and the energy industry at large. I know there's a lot of pushback from the public and from government regulatory agencies in terms of protecting the security of these infrastructures while also helping them advance with the use of artificial intelligence, like you pointed out. And so it's absolutely a challenge for the future, not only for Mr. Carter's organization, but for us as a group entering the energy industry to try and help support these efforts so we can increase efficiencies like in the areas Joby talked about, while also protecting the security of our electric grid, because that's definitely one of the biggest concerns we have in this industry. So it'll absolutely be something to continue discussing in the future and in our classes, and hopefully we can move that forward and help advance in these areas in the energy industry. So thank you all for participating in this discussion today, and hopefully these discussions will continue around the nuclear industry.